Here we have a function, we'd like to find its inverse and maybe talk about the domain and range. Write this as a y equals, and the reason I do that is because inverse means switch x and y. Everywhere we see a y, we'll write x. Everywhere we see an x, we'll write y. This should now be x equals 2y squared plus 1, and now our job is to isolate y. That'll be our inverse function. So let's do that. Let's just solve for y algebraically. Subtract 1. X minus 1 is 2y squared. Divide by 2. We have this equals y squared. And if we want to undo a square, we can take the square root of both sides of the equation. Just remember, when you're square rooting, we need to use a plus or a minus here. And so this resulting thing, after we've solved for y, this is our inverse, or our supposed inverse function. Now actually this is not an inverse function. The plus or the minus actually makes this two functions, but it does describe the inverse of our original just depending on which domain we're talking about. Now I've graphed our original function along with the dotted line y equals x. If you can imagine taking this picture and reflecting it over this line, we'd look something like this. Now in purple, this indeed describes the two functions we found algebraically, the positive and the negative. The positive part is above the x-axis, the negative part is below the x-axis, and it fails the vertical line test for functions, but we still found it. The reason this is happening is because our original function fails the horizontal line test. If we draw a horizontal line through our original function, it crosses twice, meaning it won't exactly have an inverse. But we can still compare the domain and ranges of our original picture to this supposed inverse. If we look at the domain of the original function, it's a polynomial, it's a quadratic. The domain should be all real numbers, minus infinity to infinity. The range? Well, it goes as low as 1, so it's 1 inclusive, up forever. What about our inverse function here? Well, looking left to right, it goes as far left as 1 and as far right as forever. How far does it stretch up and down? Well, it goes up forever and down forever. The range is all real numbers. And what's very interesting here is that these are exactly the same domains and ranges, just interchanged. That's because inverse means switch x and y. If domain means all the x, range means all the y, then we switch all of them. Taking inverses switches domain and range. So we found that inverse by switching x and y and solving. We did have to keep in mind that it's not technically an inverse since the original function fails the horizontal line test, but we did find a pretty nice picture and validated that when we do this process, domain and range switch.